prototyping on paper and stuff like that, and I sort of finished up his lecture. This week we're going to do a bit of sort of software prototyping because Mark's still overseas, so I'm going to start on my material. Mark will be back next week to finish off the last of the paper prototyping stuff, and then from there we'll sort of continue on with software and hardware prototyping. So yeah, we're hoping with my part of the course anyway, to provide you with skills to design and prototype interactive experiences. So we want to looking at stuff like hardware, software, physical design, all these sorts of things, and to provide you with an understanding of the interaction design process. So I mean, this sort of covers more what Mark's side of thing is, the understanding of the processes, whereas now it's to sort of try and give you some of the skills. Some of you who are experienced programmers, this will all be fairly sort of revision for you. So I apologize if it gets a bit boring, but unfortunately we got to aim for the people who don't know things rather than the people who do. But you know, it will give, maybe you get a bit of understanding on some of these tools that you may not have used before, and definitely you know, it'll give you an unfair advantage in the assignments, but that's life. So yeah, we're going to start off looking at processing. So there's lots and lots of material sort of out there on processing. This is one, we've sort of borrowed a few slides from this presentation from Sketching in Code. But yeah, basically this is, if you, whoops, where are we? Sorry, the resolution on this is absolutely abysmal. Sketching in Code and Machine Ignic. So you can see the entire presentation there. So this guy is an artist, not a programmer, and he sort of talks about, that's quite, oh, there we go. He sort of talks about his, well, programmer, designer, artist, and he sort of talks about a lot of his work. So you'll see a lot of these slides we've borrowed, but he sort of talks about processing and how it can be sort of leveraged by artists and some of the things he's done with it. So obviously he's a traditional artist. He does art media installations, all sorts of bits and pieces. So feel free to have a look through this at your leisure. He did a nice little sort of interactive art exhibit interfacing with the Wii remote. So you guys know the Nintendo Wii? Yeah, so this is basically it's got accelerometers in it and it can detect position, but he used the accelerometers basically to measure people's bodies while they were greeting and put together an interactive art installation based on how people greet. So, you know, you can see they're holding a Wiimote. I think later on he had like Wiimotes on their hands, on their bodies, and on their heads, and measured the, you know, how people from various cultures sort of greet. So, you know, in Korea they're bowing, so it tends to be a sort of quite smooth motion. In USA they're waving. Denmark is sort of hugging and stuff, shaking hands. So different cultures sort of have, you know, these different ways of greeting each other, and from that he sort of extracted the data and, you know, used that to sort of put together this art installation which used that data to draw pretty graphics and stuff. So it's kind of a, you know, an interesting look at processing, and we've borrowed some of the slides from that material so I just thought it's worth mention. But anyway, let's start talking about processing. So has anyone here used processing before? Yep. Cool. So just one person? All right, sweet. So hopefully the rest of you might learn something. So processing is a sort of Java-inspired language, or built on top of Java. It's open source, so you can go in there, you can download all the processing stuff. If something doesn't work, you can try and fix it. Only once in all the time we've been teaching the MHIT course as one of the students found a bug in processing, and we looked into the code and we decided he would just do something else. It was a bug. It was a very edge case bug. It was you know, he was trying to do something like something which was designed to deal with thousands of data points. He was trying to do it with millions of data points, and he sort of reached the upper limit of the code. It was on the bug tracker and was fixed before he finished his project, but we found a workaround for it in the meantime anyway, because he didn't really want to hack at the code. But had he been a more experienced programmer, he definitely could have and sort of submitted that change. It's cross-platform, so because it's obviously based on Java, it runs on all the desktop OSs, so Windows, Mac OS, Linux. It also runs on Android because Android supports Java. And there are ways out there to get it running on iOS as well, so you can actually run it on the iPhone and iPad and all that sort of stuff. Predominantly, it's a multimedia programming language. So for the rest of you who have sort of experienced programming, particularly in lower level languages like C and stuff like that, you know that they're really good at processing data, but as soon as you're trying to sort of start working with multimedia, like you're trying to work with video or sound or even images and stuff like that, there's not a lot of support built into the language by default. It's, you know, you sort of have to go out and find some good libraries and compare libraries and try and figure out how to interface the libraries with your project, and it sort of becomes a bit of a pain. Processing was built with multimedia sort of being its core sort of data model. So, you know, it supports images, it supports audio, it supports video. Everything has been built in a way that it all sort of ideally seamlessly joins together. So, you know, it's not like you go out and you grab some, like if you guys are familiar with C, often you go out, you grab someone's like library like for video and grab someone else's library for audio, and then you spend like 6 weeks trying to figure out how to get the two of them to play nicely together. Everything in processing has been designed so that, you know, it'll all fit together quite nicely. And yeah, it was founded by a couple of guys in the MIT Media Lab in 2001. Since then, it's sort of spun off its own life. So let's just have a quick look at somewhere in here. I've got the website open. So this is the processing website. You know, it's fairly standard, but it's got, so if we want to download, obviously we go to download. It's donation based, so you can choose no donation if you want, or you can choose to donate some money. It's open source, so it sort of helps keep paying some people to sort of manage it. You know, all donations fund the Processing Foundation, a non-profit organisation to advance the role of programming. The website's actually really good. It's got a lot of reference material on here, so you know, if we click on reference, you can see here's things, so structure stuff, so these are sort of core things in the language. So you'll see things in here which, if you've ever done any programming, are probably quite familiar, things like loop, various sort of public-private accesses, return this, true, whatever. There's a bunch of environment stuff, so this is the display environment. So when we run processing, even if we start with a processing example with nothing in it, like this, you'll see the first thing it does is create a window for us. So processing is a...
Excuse me a second, very quickly, just for anyone who wasn't here yesterday. Next week, Monday, 9 a.m., we're having our health and safety induction. So everyone needs to be there. Next week, Monday, 9 a.m.
Thanks. Yeah, so processing being it's multimedia based, it assumes everything you do is going to have at least some sort of graphical or user interface element, so it creates a window, which is kind of nice because if you've ever tried to create a window using like C++ on Win32, you're looking at a couple of hundred lines of code before you've even got anything up. Even Java by itself can be a bit of a pain getting sort of windows to pop up, whereas processing sort of it just gives you one. It's like, here's a window whether you want it or not, which you could argue whether that's a good thing or not, but I'm going to say for beginning programming, it is quite helpful. So the environment, we have a bunch of stuff we can set. We can set obviously things like the display width, display height, or call size, you know, check the frame rate, all these sorts of things to sort of affect the window we get. There's a bunch of different data types. We'll talk about that later, and composite data types, converting between data types. You can see this is a fairly exhaustive list of everything that's available in processing by default. And you can see in here there's actually a whole bunch, you know, I said once again it's multimedia language, so there's stuff in here for drawing 2D primitives, so arcs, ellipses, lines, curves, 3D primitives, so drawing 3D boxes and stuff like that. So a whole bunch of graphic stuff in there. There's stuff about input, so from the mouse to the keyboard, from files, outputting stuff, doing transforms in 2D or 3D, lights and camera if we want to do 3D scenes with lighting, material properties, stuff for reading and loading images and textures, stuff for setting up rendering, stuff for doing typography, so creating fonts, and then some math and trigonometry and bits and pieces. Then in the libraries, you see there's 6 libraries which come default with processing, so you download it, and if we go in here, you'll see there's 6 libraries which come by default. So there's stuff for creating DFX files. So processing was designed at least somewhat with artists in mind, so a lot of the stuff actually allows you to output the results of your file to some sort of image file which you can then take and print out. So, we looked at this guy, he took data from, for those of you who turned up a bit late, this was an artist, his slides are referenced in the slide material for this, but he does art and sort of technology installations, and this one was one where basically he was looking at how different people greet each other in different cultures, and he used a Nintendo Wiimote to basically track their motion and then use that motion to drive these things, and he ended up producing some posters. And these posters, like the 3D graphics on them, sort of show how different cultures greet each other. I don't know which one is which, unfortunately, because it doesn't say. But one of these would be, maybe this is how Americans greet each other if you take the XYZ thing. So this is them waving, which is obviously quite a noisy thing. This might be, the Korean or Indian way of greeting, which tends to be bowing, or at least in his examples were bowing, which is a lot smoother, sort of more controlled motion. So we get a lot smoother graphics. But so from processing, where were we? From processing, we can export straight to DXF files, which I think is what Photoshop, or one of the things Photoshop uses quite often, or Autodesk, or one of those things. So, you have the ability to export straight from your program into an image file, which you can then process. There's other things in there as well, so PDF, obviously, if you want to export to a PDF. So there's communications with networks, so you can make your programs communicate over the network, or make two programs on the same computer communicate over the network. Doing stuff with sound and video, doing stuff with serial. So later on when we look at hardware prototyping, we'll look at Arduinos. Processing interfaces with Arduinos really easily. Arduino basically runs USB over serial, and we can use processing serial communication to communicate directly with the Arduinos. So these are the default 6. Then there are a ton of libraries which are being contributed by sort of other people. These are the sort of, they've tried to categorize them, but you can see there's a lot. And these are only the ones which have been chosen to be put on the official processing website. So if you search processing libraries on Google, there'll be hundreds and hundreds and hundreds of them. Then there's some information about some of the tools. So if we open up processing, and we'll have a look at processing in a minute, there's some tools in here for creating fonts, making movies. So if you want to record a demo of your thing as a movie file and then put it on the internet or whatever, you can do that. And then some information about the actual environment, processing environment and stuff, how to use it all, and a bunch of tutorials. Bunch of tutorials on how to get started with processing various things, 2D transformations, 3D electronics, all sorts of stuff. So if this is all new to you, there's plenty of information, examples as well as books and everything else, and shops if you want to buy some sweet processing t-shirts or whatever else. So there's a lot of information on the processing site, which is great. You don't have to sort of shuffle around looking for stuff. You can just go to the processing website and find just about everything you need on there. But let's have a look at some of these things. So these were the slides for those of you who are here early enough. These are taken out of the Sketching for Code. So we borrowed some of his slides because he did a pretty good job sort of with a very brief overview. So processing is an environment. So it's a programming language, and it's also an environment you can develop in. So if you go to the processing website and you download processing, you just get a zip file, you unzip that zip file anywhere on your computer and it'll run within that. You don't even need to install it or anything. And then you open it and this is what you get. So this is the default processing environment. You can see it's basically compiling Java code, but you can add other stuff if you want. The processing IDE is actually also used for Arduino. Well, the same code bases anyway, so when you run the Arduino, actually, probably still got it installed on here. So when you run the Arduino code or Arduino IDE, which takes a while, you'll notice that it probably looks quite familiar. That's not accidental, they're from the same code base. So yeah, having a look at it though, obviously, we've got our place where we can type code in here. We have a button to run stuff, a button to stop something, create a new file, open, save, and export. So when we export, we can actually export to compilable, here we go. So we can export to executable things, executable files which we can provide to someone who doesn't have processing. So just like any other programming language, you can compile an exe. You can do the same thing with processing, of course, because it runs on top of Java. The user will need to have Java on their system. However, it does have the option for embedding Java as well. So we can create an application, and then we can basically choose which platforms we want to create executables for, Windows, macOS, or Linux, whether we want it in full screen or not. So obviously that just overtakes the whole thing, otherwise it just runs in a window, and whether we want to include Java in there, which is kind of cool. Otherwise, we have in our file thing, we have our sketchbook. So our sketchbook, in processing your code bases or your things that you create are called sketches. So it's harking back to the idea we had looking at prototyping on paper. We sketch things in processing. It's the same idea. The things are called sketches. So you can see someone's been doing some stuff on this machine before in processing. So they have a bunch of different sketches in here. And recent, obviously, is the recent ones. One thing which is really awesome is it comes packed with a whole bunch of predefined examples. So if you go File Examples, and you see each of these are categorized as well. So basics, which do a bunch of various things, topics. So I need to get you guys the books for this course. Sorry, I forgot to bring them today, but I'll bring them on Thursday, which talks a lot about processing. And these sort of follow the topics in the book. There's a whole bunch of sort of higher level demos, stuff from the books, the libraries which come with it by default, and contributed libraries, which are libraries that you've added into processing. And then, all the usual things in there. Edit has all the usual things. One of the really nice things it has is copy as HTML. So if we write some code, in processing, you'll see it has, it's a little bit hard to see, but you can see it's got syntax highlighting. So, the string constant here is in purple. If we go select that code now and go copy as HTML from memory, you'll see that it's actually, it's created HTML for a printf, and then it sets the color to purple for that. So you can actually copy and paste this onto a website now, and it will have all the correct syntax highlighting and stuff like that in there. So it's just quite nice. Rather than ending up with just plain black and white text, you can copy and paste it onto your website or whatever if you want to share it with other people, and it'll come out looking exactly like it does in the processing IDE. It's got things for auto format and indenting and stuff, so it'll indent your code. So if we break that, we should be able to auto format and it'll automatically. So if you've ever copied and pasted code off a website or whatever, you're probably quite familiar with the fact that oftentimes you paste it into the IDE and it looks like absolute garbage because in the copy and paste thing it hasn't nicely indented it or whatever. You can do that. You don't really need it, but it's a nice wee feature. Then we have to sketch, so we can run our sketch, which is going to complain because I'm trying to run it in two different modes. We can run our sketch. Oh, I'm used to using C, not processing. So we can run our sketch and we get our little window, and down here you'll see it's printed the word hello, or we can present it as well, which just runs it in full screen, which in this case does nothing because I haven't actually drawn anything. It's just printed out hello to that window, which I can't see. We can import libraries, so we'll talk a bit more about this later on. Show the sketch folder, which basically, so it's created a temp one because we haven't saved our sketch, but when we save it, it'll take us to wherever we've saved it to, which is kind of good because if you want to import any images, you need to put them in the folder that you're working in. Tools, so things like creating fonts. So if you want to do various font things, you can look through all the ones on your system, and it'll create a bitmap that you can use because bitmaps are more generic. So a bitmap font will work on any of the operating systems, whereas if you try and use like a true type font, you need a library for loading it depending on which system you're working in. Color selectors, so if you want to do some stuff with color, you can basically choose a place on the color thing, and it'll tell you the hue, saturation, and balance, I guess, I don't know, usually that's value, and the red, green, and blue, and the HTML codes as well, so you can easily get that sort of information. You can archive the sketch, which I'm pretty sure zips it up. You can make movies, and of course in the help it's got all this information again. A lot of it links back to the website. So the environment has a lot of the stuff in here. We don't have time to sort of have this huge sort of in-depth look at processing, but the great thing about processing is it has all that sort of stuff in there for you. So I figured, if we sort of show you where everything is, you guys can go off and have a play with processing in your own time, try some of these things. Definitely try the examples, open it up if there's something you're interested in doing, like load that example and try and work through it, change some of the values, so on and so forth. So yeah, the environment. You can see in this example we've got a little bit of code, so let's just try copying and writing out that code and see what we get. So if we run our default thing, we get nothing. So let's pull this over here. So the first thing we have, and I can barely read this, is size 512, 512. And of course we can step through this and run it each time and see what each command does. So size 512, 512 has made our window bigger. So I think by default it's like 100 by 100. If we use the size command, we can make the window larger. Pretty straightforward. Background 255. So if we run this now, we see the background's gone white. So, if some of these commands are confusing for you, again, we can go into the reference background, and in the reference it tells us everything. So you'll see, some of you might be wondering why background 255 was white. Background actually takes multiple syntaxes. So if we pass in one variable, it basically sets the red, the green, and the blue value all to that color. So essentially by saying background 255, we've set red to 255, green to 255, blue to 255, which is white. So, however, if we do something like 255.0255 and run that, we'll end up with magenta because that's 255 red, 0 green, 255 blue. Yeah. So if you don't understand why something works the way it does, and a lot of the processing commands can be a little bit confusing at first because they do have these sort of multiple definitions in most languages, like if you're doing OpenGL or whatever, which is not a language, but it's a library which is fairly commonly used for graphics. It doesn't provide you something which allows you to pass in one argument. You have to every time define red, green, and blue. Processing has tried to sort of simplify a lot of stuff down. Sometimes it can get kind of confusing though. Anyway, let's jump back to this. Then we have fill 255, well, keep hitting caps lock, 255, 2550. And it doesn't look like it does anything, but in our next one, so if we run our next line of code, we can see now we have a rectangle and it's yellow. So this fill command is actually setting up for the next line of code what it should fill the middle with. So we set it to yellow, we set it to red, so on and so forth. And we can do the same thing. Caps lock. And ellipse. 150, 150, 150, 150. So now we have an ellipse, which is cyan. So if you look at these commands, so rect 150, 150, 150, 150. So if we actually measured this would be from the top left corner of the screen to the top left corner of the rectangle would be 150 by 150 pixels. So the first two is where the X and Y coordinates start, and then this is width and height. So we've actually drawn a square, but we could change one of these quite easily, and we would end up with a rectangle. And then for the ellipse, it's a little bit different. So the ellipse actually starts from the center of the ellipse. So this is 150 by 150 at the center of the ellipse. And then it's the width and the height of the ellipse. Sweet. So everyone sort of can follow through that. It's pretty straightforward. Yeah, so it's processing as an environment. It's also a programming language. And, you know, it actually is a fairly in-depth programming language. So we start at beginner level, which is what we've just looked at. We can go to more intermediate levels. So let's quickly punch this one. So one thing to notice between the one we just had and this one here is the one we just had, everything was just written in basically in the top level. So we don't have, these are functions. You guys all know what functions are, more or less. So functions, basically we can group code into things and execute a number of lines of code all at once. We will be looking at a more sort of basic programming refresher in a minute. So don't worry, we'll go through this all in more detail. But we can, processing allows us to either write using functions or not using functions. So if any of you are familiar with Python, it's kind of like that, which is nice when you're getting started, rather than things like Java or C, where you need to know how to write a function before you can even start programming. So M10. All right, so this is a slightly more involved example. So now we have a little bit of interaction. So when I move the mouse around, it draws these spheres, and the spheres sort of pulsate in size. A little bit more complicated. Not actually a huge amount more lines of code than what we had in the last example, but obviously does a lot more, and it sort of introduces a few of these functions. So processing has some default functions. So it has a setup function, and this always gets called whenever the program is first run. If it's there, if it's not there, it just doesn't. So in this case, in our setup function, we tell it we want a window size 512 by 512. We have a draw function which gets called as often as it can. So as often as it can, it will basically be calling its draw function, or whenever something happens which requires it to draw. So in this case, it's going to set the fill color to red, and it's going to draw an ellipse at these two special variables, so mouse X and mouse Y, holds the mouse X and mouse Y at every position, and it's going to be drawn at size S. So we've defined this variable S up here. And then the last thing we have down here is mouse moved, and mouse moved, basically we update the value of S as 40 plus 20 times the sine of M, which we increase each thing divided by 10. So basically what this does is it's just making the S go as a sine wave. So that's what's responsible for making the circles grow smaller or larger. You guys have a play with this. I'll again make all these lecture slides available. Have a play with this, you know, mess around with that function, see what sort of cool stuff you can do. And then, you know, we can have an advanced programming language. So, you know, here in the first one here, we just wrote some code straight in there. We didn't bother about functions, anything like that. It executed it. Here we use some of the default functions, set up, draw, and mouse moved. And here we've created our own class, and our own class has our own functions and everything else. Yeah. So, you know, we can go the whole gamut from very basic sort of stuff, you just punch stuff in and it'll do it, right up to creating classes which can do stuff, have lifetimes and all these sorts of things. You can also go, if you are really, really getting involved into processing, you might find eventually that the processing IDE just doesn't cut it anymore. So the processing, any of you guys have used things like Visual Studio or Xcode or even things like Eclipse and stuff like that, will notice that there's a lot of features missing from the processing IDE. It's got a lot of great stuff for learning the language, but you sort of run into a roadblock. So one of my biggest pet peeves is it doesn't have autocomplete. So if you can't remember the name of a function, you can't just hit control space or escape or whatever to bring up a little list of functions. It's just not, at least unless they've built it in the last version, which they haven't. So yeah, if basically you either need to remember all the function names or you need the reference manual sitting in front of you, which is a pain. You can set up processing to run in Eclipse, which is pretty cool because Eclipse provides all these sorts of things. Well, both have syntax underlining, autocomplete. You can do built-in sort of content management, so you can set up with Git or SVN or whatever to share files amongst a group or whatever else. It has error highlighting and stuff like that. So you can go all the way up to using something else, and I'm pretty sure there are actually processing in Eclipse. So there are actually tutorials on the website, of course, which tell you how to install Eclipse and set up processing in it. I would recommend starting with the processing IDE just until you guys are familiar with it, but you'll probably find if you spend any great amount of time in it, you will eventually move to Eclipse because you'll just get too frustrated with the IDE. Yeah, so processing. It's a language of interaction, so can handle things like physical manipulation. You do input using code, so you can grab mouse positions. You can do stuff with presence, location, images, so hook into these libraries which do things with loading from a camera, from images, whatever else. You can do haptic interfaces, multi-touch, there's libraries to support that. You can do gesture recognition, you can do voice and speech. So all the sort of, it's designed, processing itself and the libraries which are built on it are designed to enable a language of interaction. We're less interested in things like reading from files and writing to files, whatever else. You can do that, but it's really been designed to support interaction. So be that visually, be that through keyboard, mouse, be that through image processing, reading off devices like that other guy who used the Wiimote, all these sorts of things. It's got quite a big open source community. So there's obviously the processing website, but there's also things like open processing. Oops. So open processing is basically a massive community thing where people go to share their sketches. Now in this course, I would highly recommend wherever possible, you steal everything you can, you borrow everything you can. If someone else has done something and you look at it and you're like, oh wow, that's really cool. So this is something someone's put together, and you want to have a play with it, grab their code, modify it, learn from how they've done stuff. We're not here to sort of, force you guys. You have to start, empty processing file, write out all the code yourself and stuff like that. We're more interested in seeing what you guys are capable of doing with the tools. So if that means that you're grabbing other people's code as a base to start from, I'd more than encourage it. You're probably going to learn more if you're building on top of what someone else is doing rather than you starting from scratch every single time. But one of the cool things about processing and open processing in particular is because it's written in Java, it will run in your browser. Sometimes you need to fiddle with your Java permissions to get it to do so, but you can do some, open processing, go here, and you'll be like, oh wow, this looks kind of cool. Chaos game, I don't even know what that means. Let's open it up and let's see what this is. So it's drawing a fern by the looks of it. But go on here, definitely have a look at the open processing website. So let's say I look at this one, I'm like, oh yeah, that's really cool. I want to try that one. We can then go in here and grab this guy's code. And hopefully, if we just dump that in here, there we go. Now we've got his code sitting in our processing application, and we can read through it. This guy was nice enough to comment his code, and we can play with some of these. He's got a bunch of variables we can play with to see what they do. So yeah, open processing, if you're looking for inspiration or some ideas or whatever, it's a great website to go to. There is like hundreds and thousands of like cool demos on here that people have done. And it's a multimedia programming language, so a lot of these are really quite arty, but that's what makes them cool. If you went to a thing with people with C++ code, for example, you'd find a lot more sort of more basic examples. These are things that anyone can pick up and grab and start playing around with. So huge open source community. as I said, sometimes you will run into issues with Java just because Java is a pain like that. Hopefully we can get that running. But yeah, otherwise, worst case scenario, you just copy and paste that code into processing and run it in there if you can't get it running in the browser. Brilliant. All right, let's try. See if we can just copy and paste this one in. Yeah, okay, so this one by the looks of it uses a library. So if you can't get them working, you know, you might need to have a look at the things, but I'm guessing there's something in here. It's using a library or something that we don't have access to, or there's other files that, you know, sometimes rather than copying and pasting, you can, I think on here somewhere, you can download the whole sketch. So it's possible that there's other files in there. I was only looking at one file. So let's see, open desktop. What was the name of that thing? Circle Nervous. That one? There we go. So yeah, if copying and pasting doesn't work, try downloading the entire thing and just unzipping it and opening it, because it may be that there are other files. Yeah, anyway. Open source, there's lots of libraries out there as well. So Toxic Libs is one thing of third-party libraries. And the libraries provide various things. So, you know, some popular libraries include Minim for audio, OCD for 3D camera, Physics for physics engines, Bluetooth if you want to do Bluetooth networking. So it used to be that you had to go, so if we go to like toxiclibs.org, I think it was. It's always a bit of a gamble just typing in a website like that. Yeah. So, you know, you can go on here and you can download various libraries. And if you want to install them, what you can do is you go into a computer and processing sets itself up. So you can unzip it and run it wherever you want, but it will set itself up in your My Documents processing folder. So it'll create a folder for itself and it'll put all your sketches in here, and in the libraries it'll put all your library things as well. So you can you download your library and you unzip it and it'll just be a bunch of stuff like this. One thing I discovered, which is new as of, I'm not sure how many versions ago, but fairly recently, is if you go to import library, you can see here are the default ones. You can actually go add library now, and it actually has a huge list of libraries. And let's say OpenCV for processing. So OpenCV is the sort of industry standard computer vision library. And we can just click on install and it will actually download and install that for us, which is kind of nice. We used to have to do this ourselves. I'm not 100% sure when they've added this. I have a feeling it's in the last version or two, but you know, you can see it's downloading there. OpenCV is quite large. But yeah, that's kind of cool. So let's try out example. So if we want to import a library, we just go, so let's say we want to do Minim, which does audio. We just click Minim and it will import and put all the inputs in. So if you're familiar with Java, it's exactly the same format. So import, and then we have the library name, and then we have classes within it. So the library name is called ddf.minim, and then we have stuff for SPI, signals, whatever else, and star just means grab everything in that. So to be honest, you could probably get away with just having this, because this should grab all of SPI, all of signals, everything else, but they've chosen to do that manually. And if we do Control P5, it'll also throw that in there and make it so that we can use that, which is quite nice. So yeah, the libraries basically are just Java archives, so you can make your own libraries in Java if you want to do that and compile them down to Java files. You import them just using import and the name of the thing. Yeah, we'll look at some of the libraries a bit later, but we're just sort of trying to do a very high-level look at processing at the moment. So because it's cross-platform, because it's built on Java, it's cross-platform. We already sort of discussed that. So you can run it on Android, and in fact, you can run it directly in the Android emulator or run it on your phone if you want. So there's, again, tutorials on how to get that set up and running. Yeah. So does anyone have any questions about processing at this point in time? No. So I know that was sort of a pretty fast blast through, but it's just an idea. I wanted to give you guys an idea of these are the things which are in processing, where you can use it and everything, and then we're sort of going to go back and have a more in-depth look at it a bit later. Right. So OpenCV is still installing. As I said, this is quite a large one. Yeah. And start a new sketch. So some of this will probably be extremely basic and revisionist for any of you who program fairly regularly, but for those of you who don't, hopefully it will be a nice little refresher. So programming refresher, we have various variable types. So we have the idea of a variable. So a variable is basically a pointer to a piece of memory which we can put some data in. So we could say something like x equals 1, and wherever x points to in memory, we'll have the value 1 put in there. So then if we say what's in x, it'll tell us 1. Y equals 0.5, so it doesn't have to be whole numbers or integers, it could be floating numbers. We could have characters, so characters are represented by single quotes around them. Or we can have strings, which are basically multiple characters, and they're represented by the double quotes. Then we have variables have types, so unfortunately we can't just say x equals 1, because it will say, doesn't even know what that is, my x equals 1, because it just has no idea what my x is, because we haven't told it what my x needs to be. So we have to define my x as types. So types can be ints, so integers. They can be floats, which include fractional numbers, chars, which are a single character, strings, which are a collection of chars, bools or booleans, which are true or false, and for numbers they can be signed or unsigned. So, for example, trying to think. So I think ints go to 65,535 or something like that. I can't remember how many bits they can store in there, but that'll, let's have a look actually. It should be on here somewhere. I can't remember off the top of my head how big a number they can store in them. Oh, there we go. So integers can be as large as 2,147,483,647 and as low as negative that. So if we say int, we can basically put a number between negative 2 billion to 2 billion. If we do unsigned, basically we say, well, the number's never going to be negative. It'll always be positive, which will actually allow us to go to 4 billion, whatever else. You're probably not going to, because the numbers are so incredibly large, you're probably not going to need to worry about it too much, but you will see it depending on what you're looking at. You will see on occasions people specify signed versus unsigned. So signed basically means it can have a sign, it can be negative or positive. Unsigned means it'll only ever be positive. And if you try and set a negative number to it, it will do some unexpected stuff. It'll try and make it into a positive number. And then we can have casting as well. So let's have a little look. So if I say int x equals 1, float y equals 1.5, print x, print y, run that. So it looks like it says 11.5, but that's actually just because it's printed the two of them side by side. So if we use print ln, it'll print them and then put a new line in. So 1, 1.5. If I then say, okay, actually, yeah, let's do that. X equals y. It'll say cannot convert from float to an int because, an int can only hold a whole number. It can only hold a 1, 2, 3, whatever else. Whereas floats can hold fractional numbers, so 1.5. So we can do what's known as casting, which is basically we say in brackets, we say, okay, actually treat y as an integer. And put that down there. So now when we run it, it'll go, okay, well, I'm just going to say y is an int. and then store that in X. So depending on what that value is, and depending on how it works, so Y is 1.9, it still says 1. So in processing, casting as an int is essentially just cutting off everything after the decimal place. So it says, okay, this value is 1.9, but you're telling me that it should be an int, so I'm just going to ignore everything which comes after that decimal place and treat it as 1. So if I now say that should be 2.9, I will get the value of 2 out. If we wanted to round it, there is a function in processing from memory called round, where we can basically pass in a floating point number, and when we call round on it, it will return an integer which is rounded. So if I now change that from casting to a function, you'll see now x is the value of 3 rather than 2. So rather than just chop off that last digit, it's rounded it up because it's greater than 0.5. So depending on what you want to do, whether you just want to know what the integer part of the number is, or whether you actually want to round it to the nearest integer, there are different things, different ways of doing that. And again, this may not be that useful in anything that you guys are developing. You may never need to know how to cast a number to another one, but it's fairly likely if you spend much time on things like open processing, you will see people doing it. So sort of just trying to get ahead of the curve so you can see it and say, oh, okay, I know what they're doing. They have a float and they want to store that in an int now. Sorry. Then we have arrays. So arrays are basically a collection of data types. So we can create a new array like this, and it's not print anything. But essentially what we're doing is we're saying, okay, we want to create a new array of integers. So an integer, and this symbol here basically tells it that it wants to be an array. And in that array, we're going to put the values 1, 2, and 3. So we could do print x array, and if we want to get a value out, we use those square brackets again. And this will get us not the first one, but actually the second one, because all arrays start from 0. So this is index 0, this is index 1, and this is index 2. So if we say index 1, it'll tell us the value is 2. And likewise, we could then go and change that. So x array in index 1 equals 4. So at first it was 2, so it was 1, 2, 3, and then we changed that value for 4. So it looked like this, and then we print it out again, it's 4. Cool. Everyone happy with data types and everything? As I said, pretty straightforward. I do apologize for that, but got to get through it. So it's all well and good setting up data types, but if you're not doing anything with them, it's a bit pointless. So we can do operations. So there's a bunch of, as you'd expect, there's a bunch of standard mathematical equations. So equals x plus y, print z. So if we set x to 1, y to 2, and we set z to x plus y, 1, so z is going to be 1 plus 2, and it's 3. That's great. So we have addition, we have subtraction, we have division, we have multiplication, and we have the modulo example. So let's say y, x. So basically what modulo does is it finds the remainder. So if we basically, it's like saying, okay, so this is essentially the equivalent to divide y, which is 3, by x, which is 2, and tell me what the remainder is. So 2 goes into 3 once with a remainder of 1, so it will return 1. Comparison, so if we want to do println x is greater than y. So this is greater than, this is less than, this is equal to, this is not equal to. So, true. So equal to, not equal to, less than or equal to, greater than or equal to, and then we have these two functions for and or. So if we want to know that int a is 4 int b equals 6. So let's just say we want to know if x is less than y and a is less than b. Actually, no, a is greater than b. So is x less than y? Well, 2 is less than 3, so yes it is. Is a greater than b? Well, 4 is not greater than 6, so it's not. So if we run that, it'll say false. But then if we just say, change that to that is or. So we're saying, is this true or is this true? And in this case, it is true because the first one, x is less than y, 2 is less than 3. Then we have assignments. So we saw in that earlier example, we had that weird thing like that, plus m. But basically what that does, also we'll start with these ones. So obviously equals, we know it just sets the value of something. So x equals 2, we'll set the value of x to 2. What we can do though, is we can actually do x plus equals 1. And what that actually does is basically, that is the equivalent of saying x is equal to x plus 1. So these two functions are the same thing. A lot of people do stuff like this just because it's quicker to write. Possibly a little bit more confusing to read, but whatever. So at this point, x is 2, and then we say x plus equals 1, or x equals x plus 1, and then x is equal to 3. Same thing with minus equals, we'll subtract. Star equals, we'll multiply, divide, and then we have a couple of special ones where x plus plus, we'll just add 1 to x, and minus minus will subtract 1 from x. So it's basically this is equal to that. So they all do the same things, different way of writing the same things, but you'll see all of these used, oops, sorry, that should be minus equals 1. You'll see these used in people's codes at various points in time. Okay, well, we're working our way through the dull stuff. So then we have control statements. So before, we've just been printing everything else. Printing everything out at the moment, but let's say we want to do some different stuff depending on how things go. So we have the if statement. So you can say if x is less than y, then we do this. So println x is less than y. And we can also do else, println x is greater than y. So if we run this now, whoops, I forgot to put in quotes. So we check to see if x is less than y, and it is, so we print x is less than y, so 2 is less than 3. However, and if we say x equals 5, it'll say up, so x is not less than y, so x is greater than y. However, if they're equal, in this case, it'll actually still say x is greater than y. So it basically does this first test, is it less? If so, it'll print this, otherwise it'll print that. So obviously this logic isn't working. So what we can do is we can put in another statement called else if, and it looks just like that. Now if we run this again, we should have x is equal to y. So we basically just run down like this. So we say, if x is less than or equal to y, well it's not. Else if x is whatever, and if so, run this one. Otherwise, we just continue going down. We can have as many else if statements as we want. So we could have dozens of them checking each individual thing. So we could have, if x equals y plus 1, if x equals y plus 2, whatever, doesn't matter. You can put as many else if statements in there as you want. And then we have loops. So we can have a for loop. So let's say, for. And basically, for loops have 3 components to them. So the first one, we have an initialization component. So let's say we want to have our variable x start at 0, and then we have a semicolon. Then we have our conditional statement, so how long this is going to run for. So let's keep on running while x is less than 10. And then we have our iteration statement. So what happens every time the loop runs around? So x plus plus. So we're going to increment the value of x. And we're going to println x. And let's run that. And now you see we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So what's happened is we start x as 0, and then we print it. And then we loop back around, and we start x as 0, we check to see if x is less than 10, which it is, and then we run whatever's in our loop, and then we loop back around, and then when we reach that, we go, okay, x plus plus is x less than 10, so x is now 1, yes, it's less than 10, so on and so forth. So yeah, that's very basically how loop works. You have your initializer, your condition, and your iteration, and you can actually miss out any of those you want. So we could actually have up here x equals 0, and then we just leave that first one blank. And it will do exactly the same thing. We could say, actually, I'm going to put my iteration in here, and it'll work. And then we could even do if x is greater than 10, break. And break is a special statement which will basically exit out of whatever loop or whatever we're in at the moment. And actually greater than or equal to 10. So yeah, we can actually write our for loop with as many or as few of these things as we want. So now we have a for loop which actually does nothing. Well, the for loop will never test anything. We set up x outside the loop, we do our iteration inside the loop, and we do our test inside the loop as well. And if we do our for loop like that, essentially what we've written is a while loop. So in a while loop, we only are allowed to say one thing, which is the thing which will keep it looping, so the condition. Print x. So a while loop is kind of like a for loop, except we don't initialize anything, and we don't do anything on the iteration. We basically just say keep running this loop until whatever this is no longer true. Yeah, and we can have we saw break already, but we might have something like we actually decide if x is equal to 5, we're going to break. And what that will do is it'll break out of this while function, or it'll break out of for loop, it'll break out of an if statement, it'll just get out of anything. Or what we might want to do is let's use this little function we saw before, modulo. So this is something you might see commonly with modulos. If we say x modulo 2 equals 0, that's basically the equivalent of saying, is this an even number? So when we divide by 2, is there no remainder, is what this is saying. And we can use this other keyword, continue. Oops. Put that here. Oh, whoops. Yeah, that's kind of dumb. So this is quite a weird way of doing this, but basically what continue does is it will stop running everything below this, and it will just basically go back to the start of the loop again. So if we had our for loop, it'd go back to the start of the for loop, and our while loop continue would go back to the start of the while loop, whatever else. So basically what we've got here is we say if x is even, we're just going to start back at the loop. So it's only ever going to get past this point if x is odd. So you see down here now we've only printed out our odd numbers. This is not really the best way of printing out odd numbers, but again, you may see continue in source code examples you download. You just need to know that when you see it, basically what it's doing is it's going back to the start of the loop or whatever we're doing at the moment, and it's going to stop running everything beneath it. All right. So functions. So let's just say size 512, 512, background 2502. Right, so this is obviously a function. Yeah. What have I done wrong? Oh, setup, sorry. Right, so this setup is obviously a function which is provided by processing. So whenever you first start the thing, it calls setup and does some stuff, and it is a function. So it has a return type, it has a function name, and it has some arguments. In this case, it doesn't take any. And then it has its function body, which basically is all the stuff the function does. So let's create our own function. Say now I want a function which sets up windows. So I can say, well, its return type is void. You forgot to mention, void basically means there is no return type. So it's not going to return anything. Let's say our function name is going to be called setUpBackground, and inside setUpBackground, I'm going to put my size and my background stuff, and I'm just going to call setUpBackground from in here, and it will do exactly the same thing. So this isn't a particularly useful thing because we're only saving ourselves one line of code, but you can imagine if setUpBackground had we had hundreds and hundreds of lines of code, it might get a bit tedious to have that all in the setup function. So we might decide to break that up a wee bit. The other thing, which is kind of where it is kind of useful, let me try and think of a better example off the top of my head. So actually, pop that all in there. So void draw. Fill. What's it called? Just rect. So let's say I have a function which draws a rectangle, and we will also draw an ellipse inside that rectangle. 150, 150, 50. Actually, and let's fill with that. There we go. So we have a thing which draws a box with a red box with a yellow circle in it. Now, if I wanted to draw a whole bunch of these boxes with circles in it, I could just copy and paste this code time and time again, and then I could go through and change each of these positional values. Or what I could do is I could create a new function, void draw my box, and copy and paste this in here. And then what I can do is I can actually do, I can basically say this is going to take some arguments. So let's take an x position and a y position, so int x, int y, and let's do, that starts at x, and that starts at x plus 50, y plus 50. And now if I wanted to do a whole bunch of them, all I have to do is go draw my box and say where I want to position them all on the screen. So let's do another one at 200. There we go. So now I've got a whole bunch of them on the screen. So you can imagine like there's 4 lines of code here required to draw a box. If I wanted to draw these 1, 2, 3, 4, 5 boxes, I'd have to have 20 lines of code. I would have to manually go through and adjust the x and y position for each of them in the code. Whereas here, by doing this function and allowing it to pass in 2 arguments, I can just write 1 line of code and allows me to draw a box wherever I want on the screen using a single line of code. Naming, calling, arguments, return types. So, so naming, we just basically specify the name. The calling is we just write the name of it. Arguments, we can basically put as many or as few arguments as we want in there. And in fact, we could even have another function, draw my box, with no arguments. And what that does is it calls draw my box. So now we have it. Should have probably talked about commenting as well. Draw my box like this. So if I tried to run this before, actually I'll show you. So if I try and call this function now with no arguments, it's going to tell me it's not suitable. The method draw my box int is not applicable for the arguments, no arguments. What I can do is I can now have this function which has no arguments, and if I run that, it will basically, what happens is this function calls this, and then this function calls this. So we can have various what are known as function overloads, which basically have the same name but take different numbers of arguments. So we could have as many or as few as we want, and we can call them quite easily. And the last thing, so that's, overloading, and which allows us to do optional arguments. The only thing we haven't covered for functions so far is return types. So say I have some Pythag. So say I want a function which calculates Pythagoras' theory. So Pythagoras' theory is a squared plus b squared equals c squared. So let's have a and b, and we will return the square root of a times a plus b times b. There we go. So now we have this function which will compute Pythagoras' theory for us, and we can do that by passing in a value a and passing in a value b, and we have this return statement which is basically going to return it, and we know that we're going to return a floating point value. So we can now do Pythag 1.0, 2.0, and oops, I didn't actually do anything with the value I returned. Let's print out the value. And so I don't know whether this is right or not, but maybe someone else knows. Supposedly, if Pythagoras is the hypotenuse in a Pythagoras triangle of length side 1 by 2 should be 2.23 units. So this is basically how return types work, and we can again do overloading with different return types. So we could have a plus b times b. So this function is an overloaded function, and it takes integers now instead of floats, and it returns an integer instead of a float. And now the only challenge you have to do when mixing and matching things like this is making sure that it calls the right function. So if I did, for example, one integer and one floating point like this, it's going to assume that they're both floating points. Hopefully if I pass in two integers, it'll return an integer. So if I passed in one integer and one floating point, it's like, well, I can convert from an integer to a floating point. I just make it 0.0, but I can't do it the other way. But if I pass in two integers, it'll treat them like an integer. All right, let's have a little couple of minutes break, because I know this can be quite boring. So if you need to rush off and get a drink or go to the toilet or whatever, go for your life, and then we'll come back in maybe 5 minutes. I'm wearing it. So just stop that. All right, we all good? Hopefully. All right, so we'll just pick up from where we left off. There's unfortunately still a little bit more we have to push through, but we're getting closer to the end. So we looked at functions, and now we'll just have a quick look at classes and objects. So, actually, let's skip through because we have some examples of classes. So, in fact, I put a whole section together. So, classes and objects. So you can go to the processing website and have a little read about there. And, oops, that did not copy everything. So we'll basically, there's a huge amount of information on the processing website about objects and object-oriented programming, etc., and I've stolen some of the images off here for a very quick sort of overview, sorry. So classes and objects. So basically, an object is a grouping of multiple related properties and functions. So we can just write every line of code to do something that we want. So draw a box on the screen, draw an ellipse on the screen, whatever else, move that box 2 units, so on and so forth. But when we're working on large projects, it sort of gets quite difficult to manage that logical flow. So what we can do instead is we can come up with the concept of an object and sort of say, okay, well, in my example, we probably have something which is going to do something. So let's take all that stuff that it's doing and put it all together in what's known as a class. And all that code may include things like properties. So we might have some variables in there. We might have some functions which do something to those properties, so on and so forth. So an object is a thing. So for example, we might have a car object, and a car object may have a location. It may have a speed. We may be able to tell it to drive. We may be able to say, draw yourself on the screen, so on and so forth. And then we have, and all of that, all the definition for that object is written as a class. So classes are basically the definition of an object. When you, what's known as instantiate a class, you make an object from it. So you might have a car class, and then you might have a Toyota object, you might have a Hyundai object, you might have a Nissan object. One class can create multiple objects of different types. So yeah, I've given the example of a car here, and it may have some properties or data such as its color, its location, its speed, and then we might have some functions like drive or draw. So classes have 4 elements. So we have a name. So let's just create a new sketch. Nope. So let's do our car one. So class my car. And inside that we have some data. So we might have int speed, color. There's a color variable. There we go. Color. My color. I don't know. Yeah, those are good for the moment. And int my position X, my position Y. So I didn't actually show you guys this before, but if you want to declare multiple variables of the same type, you can actually just have the type name and then just put them all separated by a comma. So these are all the properties of a car. Then we have what's known as a constructor. So a constructor basically tells us how we create a car. So we say my car. Just check so my car, and we're going to have this constructor do nothing, and in this constructor we're going to set our speed to 0, my color to green, hopefully that's something, and my position x to 0, and my position y to 0. Let's not call this my car, let's just call this car, and then we'll have a new car called my car. Just bear with me, this might not compile the first time. Yeah. Okay, I'm going to get color equals, I don't even know how to use the color object in processing. There we go, it's that round. Okay, so we have a car, which has a speed, a color, and a position X and Y. We have what's known as a constructor. So if you remember back from the very start, we talked about setup being a special function to processing, which gets called whenever our class starts. So a constructor is basically like the same thing for a class or an object. So whenever I create my car, so I create a new car here, so just like I'd say int x equals 1, I say car, because car is my object type, my car is the name of it, and I'm going to say make a new car. And this will basically call our constructor here. So if I now say println my car dot speed, it'll say 0, and if I change this up here to 80, it will say 80. So if we want to access functions or variables within an object, we have to use this dot to basically say my car dot speed, and I can have multiple cars, and I could have my other car dot speed equals 200. this one. Yeah. So now we have two cars, one called my car, one called my other car. One car is just set up by the default constructor, so it has a speed of 80, whatever else. And in the other one, after we've called the constructor, we set the speed to 200, and then when we print them out, we see one is traveling at 80 kilometers an hour, the other's traveling at 200 kilometers an hour, or whatever. Just like any other method, we can have overloaded constructors. So we could have something like this. And now instead of calling my other card at speed 200, we can do that. And we'll get the same result. So if we call the default constructor with no arguments, it'll call this one. If we call the constructor with the int argument, it'll call this one here. So it's exactly the same. And then we can have something like a method. So we might have a method drive, and that will my position x plus equal. So when we call drive, it basically adds our speed to our position x. So now if we do, let's have a draw. Update as a function, maybe not. Loop. Yeah, so there's another special function we haven't looked at yet called loop, which basically is the same as draw, but it gets called all the time regardless of whether the screen gets drawn or not. So this will get called every, is it loop? No, I'm doubting myself. Where are we? Oh no, sorry, my bad. It is actually just the draw function. We can use loop to turn it on and off. So if we do loop, it'll call draw every frame. If we do no loop, it won't call. It'll only call draw when we tell it to call draw. So sorry, I was getting a bit confused with the way Arduino works. So yeah, in our draw function, let's say my other car dot drive, and then we're going to print out my other car dot position. Sorry, these probably shouldn't have my's on them because that's just going to confuse stuff. There we go. My other car dot position x. And hopefully, when we run this, we'll see my other car is blasting off at 200. It's running so fast that we can't actually see it, but you can see it's going. If you look down, it's going at 200 things per draw time. So let's make this a little bit more exciting. Size 512, 512. Background. And let's say that this car also has a draw method. We're going to draw a filled 0 ellipse at position x, position y, 150. Actually, that should be. Bear with me here. And let's make that 20 by 20. And let's do another one at 100. Oops, and we need to close that off. And let's set this at a much more sensible level. Whee, there's my car. Off it goes. Now, the reason it's leaving trails is because So I think there are two ways of doing the background thing. So background basically will set the entire background to that color. So we can do it in the setup method. Let me just double check this before I make this claim and find out that I'm wrong. Oh, there we go. So we can do it in our setup method, which will only do it once. It sets the background to white and then it just doesn't do it. Or if we put it in our draw method, every time the frame is redrawn, it will clear the background before putting new graphics in. So you can see this now. The car is gradually, let's make that position. Put that down. So you can see here, it's clearing it every time. So every time it draws it, it clears it. If we just put this in the setup method like this, we end up getting this trail because it's drawing it over the last frame, so you just have to be careful. So yeah, now without actually drawing anything in our main class, we've got this concept of car which can drive along and draw itself on the screen. So let's change this to color. Hopefully this works. Let's just copy and paste this whole thing across. We'll do one more function, which takes a color, C, and a position. C and pause Y. And my car. So that's 1. And I'm not 100% sure how to do this actually. Oh, sorry. Do that. Oh, there we go. So now we basically set up 2 cars, and we set one to be, we say, in the default constructors, we set the speed to 80, the color to white, position X to 0, position Y to 50. We have one where we can change the speed, which is exactly the same, but we set the speed. Another one where we can set the speed, the color, and the Y position. So for one of them, we're calling with just the speed. One of them, we're calling with the speed, the color, and the Y position. And now all we need to do to basically have this little car race thing is we just tell each car to drive itself and to draw. And there we go, we've got this. Now you can imagine we'll put some interaction, whatever else, and we've got a little game where we can drive cars. Pretty boring game, admittedly, but you can see rather than having to write all this code twice, once for each car, we just have this car object, and then we can just call this car object and tell it to do stuff. We can tell it to drive itself, we can tell it to draw itself, so on and so forth. So yeah, this is sort of just looking at what we just looked at. So X position, Y position, X speed, blah, 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 blah. Draw itself, drive itself. We've just looked at the class usage, so drive and display. I was just making up the code as I went along, so it doesn't exactly match the slides, but you should be able to look at this and sort of understand how everything's happening. This is an example from the processing website. So we have a frog, and basically when we call the constructor, so new frog, we'll call our constructor, and then we pass in any arguments, and it will try and find a matching constructor. So we're passing an int, and it's found a constructor which takes an int, so it will set that. So creating a car, my car, creating 2 cars, my car equals car 1, my car equals car 2, 1 car with initial values, so we can, we've seen all this. Modifying the constructor, we've just seen that. Yeah. So I think the only thing now we haven't covered, does everyone sort of follow the example we just did? Hopefully. Tried to keep it sort of simple. The examples are all on there anyway, and if you have any questions, you can ask me after. So the only thing we have missed is the idea of scope. So scope is something which always gets people, even having programmed for 25 years, I still get stung by scope occasionally. I'm not that old. I just started programming really young. So let's see. So if I declare an int x and call it 10, and then in my void setup, I have an x and I set it to 8. Right, does anyone, assuming this runs, actually maybe if I drag that off the bottom, let's just, okay. Does anyone want to take a guess at what is going to be printed on the screen? Is it going to be 10 or 8? Yep. So it's going to be 8. Why is that? Well, because in programming we have this idea of scope, and this is often a real pain for people, because in some ways it'd be a lot easier if you wouldn't allow people to reuse variables with the same name, but you can. So we have int x10 out here, and then we have int x8 in here. This x is not the same as this x. This x belongs to setup. And we'll see if we can make it back. Apologies about that, but that's right. We'll finish up with the scope stuff, and then we'll pick up everything we were doing from everything else on Thursday. So yeah, if you remember, we had this example: x is 10 here and x is 8. Print mode x. So the scope of this x is basically to the setup function. So setup has its own copy of x, and when we print x here, it's basically using that copy. The reason this can get a bit confusing is if I now here say x, you see when setup first gets called, which will be the very first call because it's the first function which gets called. You see it says 8 because it's printing its copy of x. However, when the draw function gets called, it prints 10, which is this copy of x, because the scope. Basically, the easiest way to figure out the scope of a variable is look for its nearest enclosing squiggly brackets. So, for this one, we go back, we say, okay, we've got int x here, int x here, let's look for the nearest set of squiggly brackets. Oh, there's one here. So the scope of this x lasts from here to here. So when we call print x here, it's not going to print this one because that x doesn't exist as far as this is concerned. And for this one, int x here, there are no squiggly brackets before it. You could imagine this whole file looking kind of like that. So we go back to the nearest set. Oh, there's one there. So this x can be viewed by all of them, but it gets overridden set up. It gets even more confusing, unfortunately, because then we often see things. I'm not sure if processing what you do is what other programming languages do. Processing, at least to some extent, will prevent you from trying to do this. This will actually work, remember this works in C and stuff like that, in which case if we had printed x out here, it would be 8, and this x would then actually be within this one. So, it's just something to be aware of. If you're using the same variable name over and over again, there's a good chance, you just have to be aware that which variable you're accessing. And the other thing is, if we have int x equals 8 here, and then say you do a whole bunch of computations with x, and so on and so forth, we're not only actually affecting this copy of x, not this copy. So sometimes it's incredibly frustrating to try and debug as well, because you're like, I can see down here I'm affecting all this x values, and then it's like, eventually you figure out, actually I've got that there, and if you comment that out, then you're
So yeah, just something to be aware of. Actually, this might work. Smart processes. Okay, so it'll allow me to do that. So instead of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So in here, you see 0, 1, 2, 3, 4, and then it goes to 10. And we've got print in twice in the setup function, but this x we're printing in here is actually this one here. So we've got one x here, which only lasts for as long as this, and one x here, which references this one up here. So yeah, kind of confusing. Best way around it, don't name all your variables x. It's probably just the simplest example, the simplest answer I can give you for that. The more you use the same variable names, the more likely you are to have problems with scope because you'll actually be modifying one that you don't realise. But it's always something to keep an eye on. You know, if we had done, I guess let's go back to this example here where we had x equals x plus 3 x times whatever it was. You know, and then it still comes out as 100. If we change the name of that variable, it's going to do what we expect it to do. So try not to use the same variable names, I guess. Yeah, and scope goes for classes as well. So, you know, in here we have class car, which has int speed, speed, color, and position. These variables, their scope is only within car. So we can't down here go speed equals speed plus 1 because that speed only belongs within that car. We can, however, access those using, we can sort of access those by saying what scope we want to use. So we say, we want to access my car's speed, and then we can access it, but we can't say speed equals whatever. Cool. That's probably as good a place as any to leave it for today. I'm going to give you guys some homework. Apparently Mark is giving you an assignment that hasn't actually told you what it is. I'll get in contact with him and ask him to please let me know. But what I want you guys to do, so we'll have a lecture on Thursday as well. I want you guys to go open processing, choose a sketch, like have a look through Rails, all-time favourites, whatever, have a look through, find something you like, do your best to understand it, and then make some changes. And then on Thursday, what we'll do is we'll start it. You guys can show the demo on open processing or whatever. Then you can explain what it does or how it works or whatever, and then show how you change it in some way. It doesn't have to be a big change. You don't have to change the whole thing. Even if it's just like, you know, it does a spiral pattern and you change it to do a square pattern or something instead. Just to show that, you know, you've downloaded and installed processing, and you've had a bit of a look at other people's code to sort of get a feel for trying to understand other people's code. So yeah, doesn't have, you know, I'm not expecting you to write thousands and thousands of lines of code. Download something, change a few lines, make it do something different, and then on Thursday I'll get you guys to show what you've done and explain, or show what it is, and then explain how you changed it. Cool. Anyone have any questions about anything today? Yeah, apologies again that it's been quite dry. We had a little bit, unfortunately, because of the fire alarm, we had a little bit left to cover on Thursday, but I promise hopefully it will be getting more interesting.